Let us discuss about a beautiful machine, that is Atwood machine. It works on the principles of our previous lecture. In the previous lecture, we have discussed when the bucket is moving in the downward direction, and also we have discussed about the tension when the bucket is moving in the upward direction. So, we have to combine those two here, and we are going to achieve the tension in the tension in the string of an Atwood machine. Let us see how it looks like. This is a smooth pulley and a massless and inextensible string is passing through the pulley. Here in this chapter, up to some extent, we are going to speak about a string, means it is an ideal string. What are the characteristics? What are the characteristics of an ideal string? One is, it is massless. Can a string be massless? No. Here massless means the mass of the string is negligible when compared to the mass of the pulley or hanging masses. We are going to hang some masses. So when compared to the mass of the blocks, mass of the string is negligible. That is the first condition. What is the first condition? Mass of the string is negligible. And second one is inextensible. The length of the string remains constant, we take. So this is about an ideal string. Mass of the string is negligible and it is inextensible. And also we can speak some other word like torsionless, means there are no torsions in the string, means the blocks will not whirl because of the because of the string. Is it clear? So say this is an arrangement, this is a smooth pulley which is hanging from the roof, and this is an ideal string passing through the pulley, and the two blocks of masses M1 and M2 are attached to the ends of the string. Here our target is to calculate the acceleration of the system, means the acceleration of each block, and also the tension in the string. Is it clear? Now let us see. Here the tension always acts towards the fixed point, means towards the fixed point. Here this is a tension T, this is the tension T. And you have to remember one more thing, that is the tension in a single string always remains constant. So as it is a single string, tension always remains constant. Here it is very clear that given M2 is greater than M1. Given that M2 is greater than M1. Obviously what happens? M2 moves downwards, M1 moves upwards. Now we have to treat and calculate we have to take the free body diagrams of BD. First I am going to take the free body diagram of M2. So for M2 what's happening? M2 is moving in the downward direction. As earlier we have discussed, the bucket is moving in the downward direction. I am going to take that concept now, and I am going to write the equation here, that is M2 into G minus T is equal to M2 into A. Say this is equation number 1. Now let us take the free body diagram of M1. If I take free body diagram of M1, what happens? If I take the free body diagram of M1, how does it act? It acts like my previous case. The bucket is moving in the upward direction. It is moving in the upward direction with an acceleration A. It is moving downwards with an acceleration A. It is moving upwards with an acceleration A. That's why it is T minus M1 into G is equal to M1 into A. So the equation number 2. That's all our physics is over. Remaining is mathematics only. We have 2 equations and 2 unknowns. By using these 2 equations, we can find whatever we want. So my target is to find the tension and acceleration. Being a mathematics student or even a biology student, you have studied the required mathematics in your earlier classes. So how to find the tension and how to find the acceleration? If I add this 1 and 2, what I get? If I add these two, m2 minus g minus t plus t, tt gets cancelled, and I get with m2g minus m1g is equal to m1 plus m2 into a. From this, a is equal to how much? If I take g as common, it is m2 minus m1 plus m2. So, acceleration, what is this A? Acceleration of each block. This is the acceleration of this block, this is the acceleration of this block. But the only difference is the block is moving downwards with an acceleration A, this block is moving upwards with an acceleration A. So, when blocks are connected to a single string, their accelerations are same. Of course, we have proof for this. I will give the proof in the next session. For time being, remember this. This is the acceleration of the each block. It is moving downwards, it is moving upwards with the accelerations. Is it clear? Now, how to find the tension? Simple. Put this A here or here, your wish. Wherever you put, you will get the tension. Okay? I am not going to put this A here or here. I am not going to solve it. I am leaving it for you. You keep it and simplify for T. You will get the tension as T is equal to 2 m1 m2 g by m1 plus m2. So this is very important formula. Remember this. Okay? I am expecting proof from you. Okay? See you all.